Okay, guys, ticket timers is really not hard. So you're going to have a tape. You're going to have dots. You need to look out for the frequency. We normally give you the frequency. Whatever the frequency is, let's just say it's 30 hertz. Well, how are you going to know what the time is between dots? Period is equal to 1 over 30. What would it be for this one? What's 1 over 30?
0,033.
Okay, that's a bad choice.
Maybe just say 50.
You always get 50. Aren't you tired of that?
What about 1 over 25? Oh, yes. Yeah. 0,04, yeah. Zero comma zero.
Then you need to read the question. Are these dots representing dots, or are they representing intervals with 5 dots, or 10 dots, or 20 dots? Ugh, no. Okay, so now we have it. We've done our frequency, we've changed it to period. Now you read. If there are 5 dots, then you're going to say the time between 2 dots is 5 times 0,04. If there are 10 dots, then you're going to say it's 10 times 0,04. Whatever the question tells you, but sometimes the question doesn't tell you anything, then it's from dot to dot. So that means the time from dot A to dot B is going to be how long? 0,04. The time from B to C is going to be 0,04, and to D and to E. Now, normally the question asks you for a velocity in the beginning and a velocity at the end. So these distances are marked. So is this object accelerating or not?
It's slowing down. The dots are.
If this is my first dot, okay, so it's going faster. So let's just say this is marked off in centimeters, so that's 5 centimeters.
Is that constant acceleration?
That's what my next question is. How would you know it's constant or not? We did
Dots
it
have to increase
by
by the same amount.
the same amount. So if this one here is now going to be 10, and that's 15, and that's 25. Is it accelerating?
Yes.
No,
It jumps from 15 to 25. Oh, it's accelerating. But
It
not
is
constant.
accelerating. Okay, so if this one becomes 15, and then 20, and then 25. Yeah, because what's the increase each time is the same. This gets bigger by 5, that gets bigger by 5, that gets bigger by 5 each time. So it is constant. If it's not constant, it would be random. Okay, these are all marked in centimeters. So we don't have to put it in the diagram if we tell you somewhere else that it's centimeters.
If velocity is constant, that doesn't.
Then these distances will be all the same. Okay, so that's that. Then, so the question one would be get a velocity from interval A to interval C, for instance, for AC. So then you're going to do delta x over delta t. This should be easy for you now by now. Delta x from A to C is 5 plus 15, which is 20 centimeters, so it's 0,2 meters. Divided by how many intervals were there from A to C? 2. So it's 2 times 0,04. And your calculator does the job again. Where does it reach this velocity? Okay, remember it always reaches the velocity in the middle of the interval. So from A to C, The middle of that time interval is there at B, is where it reaches this velocity. Now if I say to you, okay, fine, go and determine the velocity for me for just the last interval, from D to G. We can choose any interval. So from D to G, what's the distance? Good, 0, comma, it's not 0, 0,05, it's 0,25. Isn't it? Centimeters, guys, not millimeters.
Isn't that E?
From D to G, it's 25 centimeters. Divide by 100. Yeah. Over T, how many intervals is there from D to G? Only one. So it's just going to be 1 times 0,04. Do you get 20? I don't know if you did the previous one right. Do you get 6,25? Okay, 6,25 meters per second. Where does it reach that velocity? In the middle of the interval, so it's between D and E. At E, it was already going faster. Remember, average is always reached in the middle. You got B right. You said for A to C, it reaches it at B. Now for D to G, it must also reach it in the middle of the interval.
We have two letters in between.
From D to E.
That's G.
No, it's not. Ours
Should
is
be
right.
E then.
Oh, I wrote G. Yeah, I see what you mean. Sorry, that's just the blobs. It looked like a G to me as well because I was writing over each other. D to E. Okay, so now the next question is always what is the acceleration? So the acceleration is always going to be Vf minus Vi over delta t. Now final velocity is 6,25. Initial velocity is 2,5. Yes.
For which section are you looking at the acceleration?
It's a constant acceleration. So if the acceleration is 3 here, it's 3 here, it's 3 here, it's 3 here. We only ever work with constant accelerations in school. So for the whole section, for the whole thing. So it doesn't matter if you work it out here. So that's why we can use any initial velocity and any final velocity. I could have used that. I could have used that. Could have used any of the intervals. Doesn't matter. So now that's the problem though, because remember it reached that initial velocity here in the middle. This is important. It reaches that final velocity here in the middle. Now you know that each interval is going to be 0,04. But you need to times that by however many intervals there are. So if you look here, it's from B, that's to C is 1, 2, and it's not 3. It's between D and E. So it's 2.5. I'm going to do it again. So from B to C, it's one interval. From C to D, it's another interval. But from D to middle is a half an interval. So I have to say 2.5 times by 0.04. And this is going to give you your acceleration.
Was this in our test or was this a past week?
This is in your book. No, I just made it up. But you've had so many of these. I did something wrong. 37.5. Is that right? Okay, now if you get an answer like this for a ticket timer tape, this is 3 times g, 3 times the acceleration of gravity. So could that be a realistic answer? Okay, I just made up these values. So it is right for here. But if you get a big answer like that, chances are except if it's some rocket or something.